Good morning, everyone. Thanks so much for joining us. We're going to be getting started here in a couple minutes, so sit back, relax, and we'll get to you soon. Hey, everyone. For those of you just hopping on the line, thanks so much for joining. We're going to get started in just a couple minutes. So sit tight. Thank you. Thanks for joining. We've still got people making their way onto the webinar, so we'll get started in just another minute. Thanks so much for your patience. Good morning, everyone. Thank you so much for joining us. My name is Amy, and I am your host of our Technology Partner Office Hours. For those of you who've never joined us before, we actually host office hours monthly. And this is an amazing session where we actually present to everyone on a topic, and we are able to answer your questions live with some of our very own Google Cloud experts. So if this is your first time joining us, welcome. And we hope that we see you in months to follow. Just so you guys know, before we get started, if you do have questions during the presentation, we will get to them after. There is the live chat to the right of your screen, so just be sure to enter your questions there, and we will follow up with them during our Q&A period. Now today, we have a really amazing opportunity for our partners. I love when we're able to do this. We are actually giving you guys really a first look at the brand new Kubeflow pipeline, as well as giving you guys some insight into the new AI hub. So this is a truly special event for our partners. And again, we appreciate y'all joining us. And to help me talk about these awesome new tools, I've got two of my friends here with me. We've got Sina, who's a TPM in machine learning on our partner engineering team at Google. And prior to working at Google, man, Sina knows everything about the cloud. He's been with Amazon, he's been with Expedia, he's been with Microsoft, and he just has this background where he can tell us, tell us like it is when it comes to machine learning. He's been really focused on consumption predictive models and our advertising platform, natural language-based search solutions, as well as computer security. So again, when I talk about you have the chance to do some live Q&A with some Google Cloud experts, this is what I'm talking about. And we also have Katie with us. And Katie is actually a UX researcher for Cloud AI, and she's focused on the machine learning developer experience with Kubeflow pipelines. Again, I can't think of two better people to be with us today. And again, I want to just thank them for wanting to come and share with us on office hours. So with that, I'm going to pass it over to Sina and Katie, and can't wait to hear about this topic. Sina, off to you.
Morning, everyone. Thank you, Amy, for that awesome introduction. So let's just dive in. I have some really exciting products and topics that I want to cover in today's talk. Quite a lot to cover, so I'll be going fast. Hopefully, we'll get to touch base on all the different topics that I have queued up for today. So what I'm going to focus on today is the platform that we released pretty recently on November 7th. This is essentially a platform that we built and put together because of the observation that we had in the market, specifically around building machine learning solutions at scale for enterprise, especially around our partner solutions when they want to provide technology and solutions to their own customers. It is extremely hard to build machine learning solutions because of lack of tooling, because the underlying platforms that we use for machine learning solutions and pipelines and deployment of them to production is essentially what we had for software development in the past. And it's just such an unnatural match. As well as the number of resources that know machine learning pedal to the metal, they're familiar with it, and they're the experts who can sit down and build the models are very far and few. So here, I like to start my slides with a story and with a problem. And here is what our partners and customers, some of you have told us. And some of these are pretty awesome and fun. Like, I love the ML experimentation is like the Wild West. If you look at the one on the right-hand side, it's literally like we have ad hoc tools, processes that are like tying 10 different notebooks across multiple different pages, and it's really hard to manage these things. I've also heard that on the right-hand side, if you look at it, we don't have an ML workflow. What we have done is taken our old traditional software development workflows and just stuck them in an ML application. I hear this over and over again working with our partners and customers. It is unnatural. It is hard. It is difficult, and the talent and experts who are far and few cannot be as effective and as efficient as we want them to be in different corporations and industries. So, having heard this for almost like 2 to 3 years now, we came up with a solution that focuses on addressing this. And this solution is essentially a three-pillar construct, where each one of the pillars addresses one of the key pain points that I mentioned earlier. First part of this pillar is Kubeflow, which, if you're familiar with it, Kubeflow has been out for about a year. It is the best of the both worlds, where we're taking advantage of the fluid experience that people have on Kubernetes, where it almost has become a standard now, where you can go to any cloud provider or any on-prem solution, and you see people are either in the process of migrating to Kubernetes or they're already running on Kubernetes. And we specialize that Kubernetes platform to make it custom-made for machine learning solutions. Now, so what does that mean? I'm going to go over in details in a few slides to touch base on what are the key things that differentiates this from a basic Kubernetes experience. But in a nutshell, think about it as we thought through all the different scenarios where a machine learning experts and an operational manager experts, as well as customers and partners, want to be able to have a platform where it's super easy to run machine learning solutions. That's Kubeflow in a nutshell. It's been out for a year. It's an open source solution. And the key value proposal there is we want to make sure we don't tie you down to a particular platform. It's built on top of Kubernetes. You can run it on-prem. You can run it on any cloud provider. And the whole goal is that you're not tied into a particular platform or solution. We'll go through detail in a second on that. The second part is talent. So as I mentioned, it's hard to find that talent. There are very few of them. Many companies have announced that they're hiring hundreds and thousands of ML experts, and they're very far and few in between. Partly because major Fortune 500 have hired as many of them as they could, Google being one of them. It's hard to find that talent who has the expertise, especially with deep learning and the latest set of technologies. So how do we make this far and few resources as scalable and as effective as we can? And we have a solution in the middle. It's called the reusable pipelines. The official name for it is Kubeflow ML pipelines. And I'll go over of how that works and what we're doing there to enable these few resources that we have, even at Google, and scale them up to be able to meet the needs of the corporation across all the different verticals. Finally, the last part of this pillar is a part that's closest to my heart, which is AI Hub. Now, if you have looked into this market for machine learning for the last 2 to 3 years, you've noticed that every month there is a new, amazing, cutting-edge, fascinating solution that comes out. And some of these are truly mind-blowing. We went from last year, I did a similar talk last year where I was talking about how many solutions came up in the last 3 months. And each one of the solutions that I was talking about were cutting edge, where if you would apply it to your industry, you could save hundreds and thousands of dollars or even millions of dollars, or do things that you were not able to do before. And this trend of new innovations coming up at an exponentially faster rate, it's actually sustained for the last while. And it is hard to keep up with it. I have a stack of papers on my desk. When I come into the office, I read 2 or 3 papers before I start my day. And I have a difficult time keeping up with what's happening. Now, what AI Hub does, it solves that exact problem. Makes it easy for corporations with internally, enterprise internally, as well as for everyone outside in the outside world to find these amazing solutions that are coming up. So let's deep dive into these. First, I'll start with Kubeflow. I shortly mentioned what are the key things in here, but let me touch base on them again. Kubeflow is a platform for machine learning that is built with the core intention of making it flexible to run on-prem, off-prem, as well as on multiple different cloud providers, as well as it is not targeted specifically for TensorFlow. This is a Google solution, but we wanted to make sure that this solution works for any other popular platform and language and model type that's out there. So you can run XGBoost on it, you can run PyTorch models on it. Anything that you can think of in terms of a machine learning solution that's out there can actually run on Kubeflow. And that's a core thing that we have focused on. Now, apart from that, we have specialized this essentially Kubernetes experience to make it suitable for machine learning type of pipelines and solutions. And part of that is building a whole bunch of different components that makes it easy to take advantage of the underlying hardware accelerators that you have, make it easy to manage and scale the cluster that's focused on doing a machine learning job. And all of those are actually built into this. And last but not least, we do have a really nice integration to different components that we have within GCP to make it easy to take advantage of those. Now, with the focus of this should run seamlessly on-prem and on-cloud in the same manner, we have those solutions, alternative solutions for those for an on-prem implementation as well. However, there are pretty awesome technologies like BigQuery, like Google Cloud Storage that you can take advantage of if you have massive amounts of data or if you want to do data crunching at scale. Now, this second part is actually pretty cool. This is the part that I mentioned. We focus on scaling the few resources that we have for machine learning at scale. And the way we do this is this. We notice that many of the machine learning models that are being built are not changed very frequently. And I'll go through some customer quotes on this and a deeper dive in a few slides. But the fact that these things don't change very frequently means that you can actually build a module and have it stable for about 6 months to a year. Now, 6 months is reasonable. Year, maybe things are changing really fast underneath. But what that means is if you could actually build a platform where your machine learning experts can build that module and encapsulate it into a library, encapsulate it into a component where nobody else has to know exactly how it works. They just need to know that it works fine and they can easily use it. That will allow you to scale your machine learning experts. And that's exactly what we have done here. And I'll go through more details, especially on this part, on how this is implemented. Now, the last piece is AI Hub. And I mentioned this is one of the key parts that I love, which is a focus on gathering all the different machine learning and data science solutions and technologies in one place for people to use. Now, let me deep dive on AI Hub a little bit. This is a pretty important solution that I want to make sure I cover as best as I can. There are two parts to AI Hub. One of them is for public content, and this is what Google and Google partners will be basically filling up and making available for everyone in the market to use. The value here is, if you have heard of any of the latest and greatest machine learning solutions that Google released, like, for example, the technologies that we have come up from DeepMind or research at Google, like AdOnet that was recently published. It's a mix between reinforcement learning and genetic algorithms, as well as like other amazing models and solutions like MobileNet V2. It's fantastic for edge deployment, image analysis on edge. These type of technologies, we publish them and we actually open source them quite frequently. But you have to go to GitHub, copy the code, set up an environment, and run it. And it is a pain. It is not easy to do. So one of the things we're doing with AI Hub is we're gathering all of these different solutions, making them available on AI Hub in a very seamless fashion, where you can click on a notebook, open it up, and play around with it, or download the pipeline and run it on your infrastructure, on your cluster, and then see how it works. So it makes it super easy to experiment with different solutions. Now, obviously, on the public side, we have our partners who will be contributing to these components. That's anywhere from our hardware providers, where they will be putting components that are for hardware specialized solutions, as well as specific technologies. Now, the private version of this is also extremely valuable. As I mentioned, it is hard to find solutions out there in the wild. That same story applies to companies within themselves too. I have friends who are sitting across me, and they were working on a solution that I didn't know about. And I read about their solution when they blogged about it or in one of our blog media outlets. And it's crazy. Like, the guy is sitting across me, and I don't know what he's working on. So to solve this problem and to enable these small assets of machine learning experts and data scientists to scale up, one of the key things that we're providing is a private version of AI Hub, where you'll be able to share content within an organization and make it easy for people to know that, hey, somebody else has already built this model. I don't have to reinvent the wheel, or I can start from where they left off. So that's easy for me to come up to speed, capture what they had, and then build on top of it, instead of starting from scratch and having to like have that tribal knowledge of here are all the solutions that are across the company. So a couple of more quick slides on this before I dive into a pretty awesome set of demo slides that I have and motivation behind the project. So the entire stack that I mentioned focuses on one thing, and that is to make this cycle of search and discovery, deploy to a limited set, customize your model, run in production, publish it as an official solution, and then repeat this cycle as you get feedback and as you discover new things as fast and as quick as possible. Right now, this cycle can take up to a year. And I'll go through some anecdotal examples where partners and customers have shared where they deal with this. Imagine if we can bring this cycle to as short as weeks or a week. And that is not an unimaginable solution. That's actually possible today. That's really what we're focusing on. So last thing, what are we putting on AI Hub? I think this is a very important part. AI Hub is not just for machine learning ML pipelines. We are focusing AI Hub to be the central place where you go to find everything and anything you need for data science and machine learning solutions. This is the single-stop shop where you will have all the different technologies, courses, as well as material and data sources that you would need for machine learning. And this is pretty awesome, like a unified place where you can find all of these amazing assets. Now, lastly, one of the key things I want to bring up is this entire stack of platform that I mentioned is not really focused on machine learning experts only or data scientists only. The range of people that business roles and people that we're focusing on is pretty broad. We're looking to build this platform in a way that it can serve the needs of a business analyst, where they may not necessarily care about what details of the machine learning model that's being used underneath is. They just want to know how it behaves, if it works properly or not, and they just want the answer, and that's it. Basically, they want a proof of this works correctly and an answer. All the way down to the data scientist and machine learning expert, where they want to slice and dice the data, play around with different features and so on. We are targeting to build this platform in a way that addresses the needs of the entire spectrum that you see here. And that's a pretty aggressive goal. But at this point, I can say we've gone a long way. We're actually pretty far in terms of getting there. So let's quickly touch on motivation. Where did this come from? Why is this such a big problem right now? Stories like this has really motivated us to focus on an end-to-end platform instead of just solving machine learning components. I've heard this over and over again. It takes about a week, 3 weeks to build a machine learning model on a Jupyter notebook on a single node instance. And that's it. You have your model. You have your machine learning model that solves the problem. But it takes a long time to take that model and put it in production. And the things that go around this are extremely complicated. That's where the code that software development solutions or lifecycle management tools that we had for software is now being used for machine learning, and it's a misfit. And that's where these problems and pain points come from. So what we're doing is we're focusing on building everything else around this problem, not just the center part. So the ML machine learning part, the Jupyter notebook that most data scientists have, is that central piece. But we're focusing on making sure everything else around this works seamlessly, effectively, and efficiently. And that's really the key takeaway from what we have put together as a platform. Now, let's actually deep dive into what the pipelines are. And I have a couple of demos that I want to show you. I think that those are pretty fun and exciting to look at. But let's quickly go over the key pillars of what are we doing with pipelines. We have built 3 distinct abilities. One of them is workflow orchestration, and this is to allow us to run, schedule, rerun an entire workflow of a machine learning solution, and that includes pulling in the data, doing data transformation as needed, data sanitization and transformation, building a machine learning model, doing validation on that machine learning model, and pushing it to production, and a serving platform as needed. Also, we enable rapid and reliable experimentation. I'll show you a really fun demo for that. And then finally, the ability to share and reuse components. And that's where I said we enable machine learning experts to scale as needed. Now, before I go any further, what is the magic? How are we doing building these Lego pieces? How are we building these components that are reusable, well-defined, and you can connect them together? It's actually very simple. Underneath, what we have is a combination of Docker container and an orchestration engine. Right now, that orchestration engine is based on Argo. So what we're using underneath Argo to orchestrate these Docker containers, which each Docker container is essentially that Lego piece. It is that component that you define. And to make it seamless and easy to author these things, and also to make it scalable and flexible for future changes, we have put a Python-based language on top of this orchestration engine, which is our own SDK, essentially. Now, what this enables us to do is to have flexibility to add additional connectors, additional features and components that may not necessarily be available in Argo or in any other orchestration engine that we found online. So we looked at a couple of them. We looked at Airflow. We looked at Argo. If you're familiar with them, each has its own pluses and minuses. And we found that data scientists, especially and machine learning engineers, they love Python. Everyone's starting to love Python now. So the SDK, the domain-specific language that we have built for this, is actually written in Python. And underneath it right now leverages Argo to run the orchestration engine. And each one of the modules that we're running is essentially a Docker container. Now, how does this look like? We have a visual that lets you see how these are tied together. And you can actually go through the execution and see how each step is doing. So if you have an RCK or other artifacts, you can actually very quickly see how that particular component is doing. So for example, we have a training component here. You can quickly look at the RCK to see how the model is behaving. We also have ability to see the configuration and change the configuration as you need to do different experimentation. And I'm going to go through a live demo here. So let me actually, this is a great point for me to stop and show you this in action. So let me quickly switch over. And what I'm going to show you here is essentially an instance of ML pipelines that I've deployed. So I have a Kubernetes cluster that I'm running this on. And on my Kubernetes cluster, there are two different distinct things. One of them is underneath, this is running on Kubeflow, but on top of it, I have the ML pipelines UI. This is what you're looking at here. And in here, I have the pipelines that I've built before. I have a number of experimentations that I've ran. So you can look at my past experiments and then see what was happening there. And I also have a link to notebooks, and that's the authoring experience that I'm super excited about. So when you click on notebooks, this page pops up, which is essentially my Jupyter notebook experience. If you like the lab Jupyter Hub lab experience, you can also switch there and then see it in Jupyter Lab, whichever is your preference. Now, with that, let me dive into a couple of the examples that I mentioned, just so you can see it live in action and see how it works. So here I have an experiment, and tests and trials and things that I verify and run are grouped under an experiment bucket. An experiment could be with different models, different types of solutions. So I have like an MNIST CNN example here. I have an XGBoost example. It's literally an arbitrary grouping for different things that I try out under one setting. Another cool thing is, as I have those settings, I can actually look at the runs and see the results very quickly and visually. If there's an RC curve or if there is a confusion matrix, I can very quickly look at that. Now, a very powerful part of this is if you want to play around with multiple different model runs and create a new clone and see how that works, the rapid experimentation part. We actually have an awesome solution for that. So here this morning, I actually kicked off 3 different runs. And the way I did that, let me show you how that actually works. I went to one of these runs. I had it running, and maybe I wasn't happy with the results. So I looked at the configuration, and maybe I ran this for about 100 rounds, and I wanted to see how it looks like if I run an extra 50 or 100 rounds. I can very quickly clone this and then create yet another run. And let's call this XGBoost sample 4. And I can change any of these parameters as I wish to. And notice I'm changing these by hand right now. There is an SDK. You can actually do this automatically and programmatically, especially if you're doing hyperparameter search. You can kick off many different runs with different parameters. You don't have to use the UI for that. And I will show that in a second. But here, that simply, I just created a new run with different parameters where I'm going to see the results and be able to compare that run with the previous runs that I ran this morning. Now, let's have a quick look at this. This run is kicking off. It's setting up some nodes in my Kubernetes cluster and essentially starting to execute on that particular run. And as it does that, I have the output from that particular node, so I can see how the node is performing. If there are any issues, I can deal with it. I know what the input to that particular step of the pipeline was, and as well as if there are any artifacts, I'll be able to see them. Now, the cool part that I wanted to show is actually over here. Imagine I have multiple of these runs, and I want to quickly compare all of these different parameters that I did and see how they actually perform. I can select them, and then click compare, and I can very quickly see what the parameter difference was. So in this case, I was playing around with the number of rounds that I'm going to run the XGBoost algorithm on top of my data set. I'm using the same true label. I'm using the same number of workers, but there are a whole bunch of parameters that are user-defined, and you can modify these to your hard content as you want to play around with different things, or you can use hyperparameter tuning to find the perfect parameters for your particular run. But I can also look at the data output and even see the confusion matrix to quickly see how much improvement did I get based on that data set. So as you can see, there's slight improvement or slight difference in these different runs that I had over here. Now, there is another visual that I want to show, and this is super exciting, especially if you're a TensorBoard fan. If you're not, you definitely need to play around with TensorBoard. That is one of the best tools for analyzing models. Now, imagine I have a model that actually uses TensorFlow. And the taxi cab example that I have here, it's a complex pipeline. Let me actually show it to you. It basically pulls in some data, does some data pre-processing, and then trains a model. And as you notice, one of the artifacts that I have here, which is a built-in supported feature, is I can quickly kick off a TensorBoard instance and look at the actual output. Now, I'm not going to do that here. I'm going to come back to this page and show you something even cooler. And that is, imagine I want to run compare all of these runs that had a TensorFlow instance in them, or an output that can be consumed by TensorBoard. I can select them and I can hit compare runs. And same results as before. I can quickly see which ones succeeded, which ones didn't, how much was the runtime, and what were the parameters that were different between these different solutions. But the coolest thing is over here. I can actually see an aggregate view of the results in TensorBoard. And if I open the TensorBoard here, I can actually see all of those runs side by side, super easy, and see how the training went, what was the loss or log loss function results for this particular run. And that is extremely powerful. I frequently have about like 40, 50, or like 100 runs that I have, especially if I'm doing hyperparameter tuning. There's a ton of different results that comes out quickly. And I need to very quickly find that 5 different parameters that are useful for that particular run. And this allows me to very quickly compare them, find the 2 or 3 that I want to focus on, and then continue my experimentation there. And that's extremely rapid experimentation. So I think those were the key things that I wanted to cover here. Now, we are going to go back and go through an authoring experience. So I'm going to completely shift mindset. That was the view of how you actually do the experimentation, how the rapid experimentation works. Let me take you back to the data scientist world. And this is the ML expert world where you're actually building these individual components. Now, if you have any ML expertise background and if you're in this field, this part is going to be magic to you. One of the biggest pain points I've heard from our partners and customers is they hate to step out of a notebook environment. In fact, our deep learning notebook images are one of the most popular solutions because you deploy the VM and you have a notebook up and running for you like that, and you don't have to worry about anything else. Now, what we've done here is we've essentially built a DSL set of libraries. These are domain-specific language libraries that allows you to do everything that I showed you through the UI there and through other tools that you have to do, all within the notebook. So let's go through an example here very quickly, and then I'll show you a deeper example that walks through this in more details. So the example that I have here is we're going to author 2 individual components and build a pipeline out of them. So it's a very simple pipeline. It has 2 pieces. What I'm doing is at first I'm importing our DSL library. So this is Kubeflow pipeline libraries. And then I'm authoring one pipeline, and this is a super simple pipeline component. All it does, it gets 2 floats and adds them together and returns the result. So not super magical in terms of machine learning, but just want to demonstrate how easy it is to build these things. And what I do here is I use one of our functions to actually build this into an actual container function. So this becomes one of the modules that we're going to run. Now, once I run that, I'm going to create a different one. This is my div. It's basically going to grab 2 numbers and return the div for it. So here's the function definition. And the cool thing is, because I'm in the IPython environment, I can actually try this output and function right there before I submit it and build a Docker container out of it. So very quickly, I can actually run this and see, yeah, it actually sounds reasonable. It works and everything is fine. I didn't get any errors. Now that I'm convinced that this works, I can actually go ahead and package this. And finally, I can actually go and build a pipeline out of it. So now I have, up to this point, I have built two different components. One of them is this div mode component, and then the second one was this add up component. So what I'm doing here is I'm defining a pipeline. I'm saying this pipeline has 3 parameter inputs. 2 of them have a default value. 1 of them doesn't have a default value. A doesn't. And I'm going to explain how this pipeline is basically working. So first step in the pipeline is I'm going to add A, which is an input parameter, and a value 4. And then I'm going to create a div mode based on the output of the previous step, the add step, and one of the parameters that we passed in, which is B. And pretty much that's our pipeline. So let's go ahead and create this. And now I'm going to compile this into a package that I can submit to my ML pipeline. So I'm going to go ahead and create that compilation. What that does on the back end is actually creates this tar file. And the tar file, what it really contains is just Argo file wrapped around in a tar file right now. We chose to wrap the Argo YAML file, this is the execution YAML file, in a tar file. So if you want to add additional access to it, we can do that in the future. That's really why we have wrapped it around here. Now, the last step is I'm actually going to go ahead and run that step. And what I'm doing here is I'm setting some parameters. So I'm saying I'm going to send the values 7 and 8 for A and B, and C is going to continue having that default value of 17. And what I'm doing is I'm actually creating a new experiment or getting a list of experiments and using one of the existing experiments to run this particular model under. And once I do that, it gives me a nice link here where I can just click it and the experiment comes up. We can see that it has already started and the first step has completed in there. And we can see what the input to it was and what the output was. Now, the div mode split is pending with a message container creating. So it's actually in the process of creating the container. And in a few minutes, as soon as I have a container freed up, and just a quick note, I'm actually, if you remember, I kicked off this other process that's using most of my resources right now. So that's basically queued up until this this first step frees up. And as soon as this frees up, it's going to take up the next job and actually run it. Now, this was how easy it is to actually use and build a component here and use it. Now, there are 2 ways of building components. This is a rapid way, which is extremely fast. You can also, if you want to, at each step, build a Docker image, which will be used as that module. So you don't, in this case, we're actually injecting the code as an add-on to the Docker image. However, you can actually build a full-size Docker image for each step as well. Usually, after you do go through a couple of experimentation like this, you build those Docker containers that they become the asset and we publish them to the AI Hub. So that's more of a finished step, but if for rapid experimentation, this is what the path is. Now, all of the things that I showed you right now are actually available on our GitHub repo. And not this one, it's actually this one. Under Kubeflow pipelines, you can actually find all the samples that I mentioned, and not only the samples, but you can also see the notebooks. And do you remember the complicated pipeline that I ran at the beginning, which is still, I think, running here? Let's actually have a look and see how these things are doing. Oh, actually, it's made quite a lot of progress. It's done its transformation, it's done its analysis, and it's right now in the training step. So this complicated pipeline that you saw here is actually available as a notebook as well. So you can go there and have a look at the notebook and see how each one of the modules in there are authored. And also you can see some of those like fancy UIs that we were outputting, like the RC curve and as well as the confusion matrix, how basically those things are generated and how the data output is actually passed down to them. So a lot of these components are off the shelf, ready to use, so you don't have to rewrite your own visualizer. Our job here is to make it super simple for you to use those. So basically what we did, we just went over this authoring experience and how things work. However, remember, all of this content is available on the GitHub repo. We covered the rapid experimentation and how quick it is for you to build a pipeline, try it out, see how it is. We also talked about how easy it is to clone a new job and see that new job running with different parameters and then doing a comparison, popping up a TensorFlow board if you have a TensorBoard output that can be consumed by TensorBoard. And then finally you can actually see all the runs. You saw the visual where we can see how the last like 5 runs have been. Do I have any failures? Now, there are a couple of cool things that I didn't deep dive into. You can actually schedule runs. So as you're cloning a run, you can actually have it scheduled to run on a frequent basis. You can, or you can have an instantaneous run. If your assets are not available, the job will queue up and it will run when the assets become available. That's like the last one that I just showed. Now, finally, let me actually go over here. I want to show you a couple of these. It's just pretty awesome to look at them here. I showed a couple of samples of how you can see the results side by side. The tensor board is my most favorite result set. However, other things like precision recall curves and RC curves, you can also see them when you're doing compare run. So as you have different runs that you're going through, you can actually have a quick look at them. Now, one thing that I mentioned was share and usable components. As I was defining those components, the add component and the div component that we just saw, now anybody in my organization can actually grab that component and use it to build a new pipeline. And that's one of the extremely powerful pieces here. Because imagine this is a very simple example. Imagine if the example actually is very complicated. Like one of the pieces could be actually something as sophisticated as the MobileNet selection. And imagine I want to be able to experiment on MobileNet v2, for example, one of my favorite models. If you haven't heard about it, spend some time, look at this repo. And you want to build multiple different iterations of it. What this model allows you to do is to basically build different architecture sizes for different devices. So if I have a super powerful device, I can build a model which takes advantage of maximum number of operations and then produces a pretty accurate result set. If I want to do a trade-off between accuracy and a smaller model, I can drop down to only million operations per second for that particular million operations per run for that particular model and lose a little bit of accuracy. Now imagine something like this. I can run it in a matter of seconds and experiment with all of these different architectures in no time to see the results. So that's extremely powerful. Now I'm gonna show one last thing here before I pass it down to Katie, which is how does this look like in an end-to-end operational production system? You might be familiar with TFX. We're essentially building and optimizing what we have been doing inside Google and making it available for everyone. A TFX pipeline looks something like this, where we're pulling in data, doing some data transformation and data validation, and then finally running a machine learning model. Now, this is the stuff that everybody thinks this is the end of training a machine learning model. We have a couple of other really important pieces in there as well, which is TF model analysis. Now, this is a key component that we're putting assets in. And this allows you to understand how a deep learning model works. It is so difficult to understand nowadays, or up to actually like 6 months or a year ago, to understand how a deep model worked, that most people would actually shy away from it for financial, FinServ sector or other sectors that you need to know what is the behavior model in an aggregate, like for example, what is the distribution of the results of the model, as well as how did the model make a decision for one particular case. If you've heard about the research that University of Washington did, Lime, there were some initial steps in terms of addressing that concern so that you can actually understand the deep learning model in the same way you understand a tree-based model. We are doing a lot more there. Google has done a significant amount of progress in doing deep model analysis, and now we have capabilities to give a pretty good insight into how the model behaves and why a decision for one particular case was made. For example, imagine you have a loan application and it gets rejected or it gets accepted. You want to be able to say what features and what parameters contributed to that acceptance and rejection, even when you're using a deep learning model for that. And those capabilities are things we're focusing on, and we believe that will open up a major part of the industry. All of that is going to be available and built into the pipeline. Now, the last piece is the serving part. This is not usable unless you push these to production, push things to production, and you have a serving platform. And we do actually have that as a part of the Kubeflow and ML pipelines. And it's not just unique to Google and TensorFlow serving solutions. It is a platform, as I mentioned, for all possible serving infrastructures. So for example, the code is open and public, so you can actually see it by yourself. But there's a check-in coming up from our friends at Intel, who have actually integrated one of their awesome model transformation components that allows you to transform a TensorFlow or PyTorch model into a very specific architecture that you're targeting. And there are additional components like that we're working on to integrate into the underlying platform. Now, that's all I had. With that, I'm going to pass it to Katie to tell you about some of the exciting things that we have coming up.
Thank you, Sina. Hello, and I wanted just at the end here to extend an invitation to you to get involved with us. We love to speak with our partners, and we'd love to have you involved in our usability, user experience studies. And there's many ways to get involved. If you are willing to fill out the short form, and Amy will send you a link soon after this presentation. But it's got 3 short things to enter: your name, your email, etc. And that will allow us to reach out to you to get you more involved. We can do interviews with you to understand your needs and your particular machine learning workflows. So we really want to hear from you, because we're really excited about these products, but we know there's more we can do, and we're always improving. So if we hear from you and your needs and your particular machine learning workflows, we can make these products even better. So please sign up. We'd love to speak with you personally. And there's also another opportunity, which is if you can sign up for the AI Hub Alpha. So this allows us to reach out to you to do a deeper engagement on using the AI Hub that Sina was talking about. Filling out the form does not guarantee access, but if you have experience with Kubeflow, if you go in and you try the Kubeflow pipelines that Sina demonstrated, that will give you sort of a priority in the list to reach out to, because it does help with getting involved with AI Hub if you have some experience with that. So please jump in and try the tools, try Kubeflow pipelines, sign up for the alpha, and fill out the form to get involved with our studies. We'd love to speak with you. So thank you. And with that, I will hand it back to Amy for Q&A.
Awesome. Thank you, Katie, and thank you, Tina. This, everyone on the line, I have to tell you, working at Google is maybe the most humbling thing anyone could ever do, because it's so incredible what our teams develop, and it's so incredible that the impact that these products have. So I'm so glad that Sina and Katie were able to join us and share these experiences with us today. As Katie mentioned, we are ready for Q&A. So when you guys are ready, go ahead. I know we already have a couple of questions in the live chat. Again, just go ahead and type your question into the live chat at the right of your screen. But before we dive into those questions, one of the beauties of Office Hours is that it gives us a chance to share with you, these great new products, but also some amazing new resources that we have for you as partners. So I just wanted to remind everyone on the line a little bit about our partner Quick Starts. Quick Starts really do help you to build brand new solutions. These are a great one-stop shop as you're looking to improve solutions that you already have, maybe start in a new practice area. And we have several Quick Starts out on the Cloud Connect portal that you all can access today. We just actually very recently launched a brand new Quick Start around G Suite. We also have Quick Starts out there around IoT, IoT device integration. We even have some data analytics Quick Start. We're going to continue to add to this library. So again, just wanted to flag it to you all as hopefully your creative juices are flowing after today's presentation. If there are other areas you wanted to explore as well, that's a great space to start. So with that, let me go ahead and jump into our questions. So the first question we have here is Kubeflow also applicable to NLP-based pipelines and Spark/Dataproc compute engine?
That's a really good question, and the answer is yes. To make it very short, I'm going to quickly jump back to the actual repo, and I highly recommend everyone to just go check out the repo, play around with this. It's an awesome tool, and it's super easy tool to set up and play around with. But one of the examples that I showed was the TFX pipeline. And TFX pipeline and XGBoost. Now, let me actually go back and bring up the XGBoost one. That is actually connecting on the back end to Dataproc and running the job on Dataproc. So that's an example of a solution that utilizes other underlying platform pieces. Now, in terms of what other machine learning solutions or technologies or specific machine learning areas can run on ML pipelines, NLP solutions, absolutely. Anything else that you can think of. Classical machine learning solutions like random forests or tree-based models or Bayesian models also work. Think of it, for lack of better word, think of it as an operating system for machine learning. That's really what we're focusing on, and we're partnering with key players in the industry to make sure that this is truly an operating system for machine learning across the board, that you can run any and every machine learning solution that you want to on top of it.
Awesome. Thank you, Sina. We have a question here about whether or not you guys are going to be receiving the links for these studies that Katie mentioned. Yes, absolutely. If you have registered for the session, you will be getting a follow-up email from me, or I'm sorry, from Google Cloud Tech members at google.com that will have those links. Also, all as is true with all of our office hour sessions, they will be posted on the partner portal a couple days after the session, along with the slides. So you will be able to also access those slides via the Cloud Connect portal and click through there. So we also have a question here about training as it relates to AI ML. Well, this is also just a really great plug for us as a program, and you guys keep hearing me mention the Cloud Connect portal. It's because that's really a great one-stop shop for you guys. As partners, you do have access to free training via Coursera. If you go onto Cloud Connect, you'll be able to fill out your request form to get your free voucher for a Coursera training course, which has a ton of different training opportunities for you. We also provide access to quick labs, hands-on labs. So if you want to play with some code, that's a great place to do it. And then, Sina, I know that you and I talked about some different Kubeflow training opportunities on CodeLab. Do you want to share with the team, with our partner family here, what that looks like?
Absolutely, absolutely. There is an actual code lab specifically for Kubeflow. So let me quickly bring that up. That you can actually go in and get hands-on experience with a very nice walkthrough, step-by-step introduction to what Kubeflow is. We are also working to build additional components for specifically ML pipelines and trainings for ML pipelines. So there's a lot of content that's already available for Kubeflow. These code labs they're awesome. I love them. You can very quickly, in a very short time, like 20 minutes for running through this entire session, get a really good hands-on experience and a great place to start to learn more. There are links in there to the assets that you need if you want to go further. But these are fantastic tools to learn and ramp up on solutions. As well, I'm going to just mention this one more time. There are fantastic samples and fantastic notebooks. With the two notebooks that we have already are up there for a quick introduction to how to run pipelines. The actual instructions for how to set it up is also right up on the page. So if you go to Kubeflow pipeline page, there is a link to our documentation and how to get started here. And a couple of awesome blog posts. Lack is one of my heroes in terms of blog posts and ML AI solutions. I copy a lot of his work as I do presentations and talks, and he has a couple of awesome blog posts on this as well in terms of how to get started and jump in and try things hands-on just to see how simple it is, how easy it is, as well as how fun it is to build your own machine learning solutions on top of Kubeflow pipelines.
Awesome. And keeping on that lovely Kubeflow topic, we have someone that wants to know how Kubeflow can help serve large-scale fintech organizations.
Awesome question. Again, there's a lot. So the part of the talk that I mentioned about model analysis, that is really one of the key focuses there is for financial industry. And I think it was over this slide. If you look at the last step for TFMA, a key component that we are focusing on to enable financial industry to take advantage of the latest and greatest solutions that we have in deep learning and machine learning is ability to understand how is this black box model behaving, how is this performing, as well as for individual decisions, what was the key factors for that particular decisions. And what we have noticed in the last while, that has been a big blocker for financial industry adoption of deep learning solutions. Now, there's another part of this that's already solved, and Kubeflow takes advantage of the underlying platform that I want to make sure I mention, and that is Google Cloud Platform has a pretty broad range of security and compliance and government regulatory certifications already met. And Kubeflow is building on top of Kubernetes. So if you're running Kubernetes on Google Cloud, on GKE, you're already taking advantage of majority of the certifications that we have already available on Google Cloud Platform. And easy way to find all about it is if you go to Google Cloud security certification. We do have an awesome page on Google Cloud that actually demonstrates all the different compliance regulatory requirements that Google Cloud already adheres to, and it's a pretty broad list. And it's just something that I kind of feel like we, as an ex-security expert, I kind of feel like that we don't talk about enough. And there is a ton of content and data here that you can actually go through and deep dive and see for individual industry verticals, like, for example, financial services that we mentioned. What are the different regulatory requirements that we adhere to, and how that works with Google Cloud? But to put it in a nutshell, we do have an extensive support for privacy security requirements like PCI compliance, SOX compliance. There's a lot of them adhere to in the underlying infrastructure. And the beauty about Kubeflow is that it builds on top of that amazing infrastructure and platform.
Awesome. Thank you so much, Sina. Well, it looks like we've gone through our questions. Again, I want to just thank everyone again for joining us today. This is our last office hours of 2018. So thanks to everyone who's been with us for the year. Make sure to be with us when we come back in January. Actually, starting in January, every month we will have two office hour sessions, one focused on more technical topics like today, and the other focused on kind of the more programmatic business side of the house, so we can help you guys further look after your entire partnership with us. So stay tuned. Those are going to be super fun. Again, you'll get some emails about that coming in early 2019. And just another huge thank you to Sina and Katie. You guys rock. You're brilliant. Always fantastic to hear from you. So with that, I hope everyone has a fantastic rest of their week, a wonderful holiday season, and I'll see you guys next year. Thanks so much.
Thanks, David.